Hello, welcome to part two of the revision. So let us begin. Let's continue where we left off. So let's see. We had we had let's check what we have so far. Okay, so we had created the record structures, a structure representing the game and a structure representing a player's location. And then we have the enumerations, the enums, and the two-dimensional array. Yeah, so I think we are good to go now. So let me just do this. Okay, no, okay, I'm just gonna leave that. So let's start creating the functions, right? So let's create our functions. Remember that the functions, they follow an input-output procedure, right? So it takes in some input and then it performs some specific process, and then we then get some output. And the output can be in, in different forms. You can have output in such a way that the output is actually being given to you, like handed to you directly, or it can just be like let's say we're printing something. We can't really say that that's like the process, that's what we've processed. We haven't done any process yet. So I'm gonna remove this and just do a quick demonstration on functions. So let's say I want to do a function that finds a maximum between two values, right? So it takes in int a and int b, right? So it should return the integer, the maximum between the two values, right? So this is the syntax of a function. You start by specifying the return type, a return type, and then a space. There's the return type, it's an integer, and then followed by a space. There's the space, and then followed by name of function, the name of the function, and then followed by open bracket, close bracket. And then inside here, we're going to have a parameter list, right? So you can also rephrase it like this. It can be like this, it can be this format. You can say that it's going to be parameter one, right? And then you specify the data type, then followed by another parameter, then followed by, you're going to have an infinite number of parameters. You can have as many parameters as you would like to have. So I was just doing a quick demonstration on that. So let me enter full screen. Okay, there we go. So as you can see, this is the structure. It has a return type first, and then it's followed by the name of the function, and then it's going to have a parameter list. And the parameter list is in this format. The first thing that you put in, or is the first thing that you specify, is the data type. Remember, computers, you can say they are those, how can I phrase it? Computers, they take things in a literal manner, in a literal sense. So you need to be very literal and like explain everything step by step. You can't just say, okay, you're gonna take in some parameter, some value, and not specify what type of data that value will store. So you need to specify what type of data by specifying the data type. The data type is basically saying what type of data will this variable have, or this first parameter. Remember that each parameter is separated with a comma. So the number of parameters in this function is 2 because I've separated it with the comma. So the first one is the one that's on the left and then before the comma. Then the one after the comma, it's another input. So everything that you see here, it's going to be inputs into this function. And there's two ways you can use a function, to be honest. You can just specify the type to just say, okay, I'm going to take in two integers. But the problem is with this approach, right? This approach, it is a problem because now I won't have a way to reference this first parameter and another way to reference the second parameter. I won't be able to do that. Remember that this function is meant to compare. It's meant to find a maximum between two values. So that's why I need to sort of like create a variable so that I can reference that first that parameter or that input. So when I say int a, I can use a to reference and say to reference the first input into this function, which is the first parameter. I can reference it now and check what value it has. So for example, if a is equals to 10, then see out um, see out a has a value of 10. So that's what we're going to output, right? So something like that. I'm able to reference and check what is the first input into this function. So let's just test it out and see. So let me just do this max. This is how you can call the function. You don't specify the type anymore. You use the function. You just write the name of the function followed by the inputs, basically your parameters. What are the inputs? Let's say the first value is going to be 10, and then the second one is going to be 19. So this is how it looks. So it's gonna find, okay, for now we haven't written the code yet for finding the maximum, but it's gonna find a maximum between 10 and 19, between the two inputs. So let's check. So you see, how is it able to say to output this? It's able to output this because I had a way to reference the first parameter, which is 10, this 10. So in this line of code, right? In this line of code, what happens is that it's going to say A is equals to 10, and then it's going to say B is equals to 19. So now we can reference it using these two variables, A and B. We can reference these two inputs. So that's something very important. And with the return types, right, you can have an int, any data type as a return type. And you can also have what we call void. Void, it means that it, you don't get back anything. So for example, if you look at this, or you can view void as, you can just, in a way to just better understand and remember this thing. When you have a void, it means that there is nowhere within your function a return statement. You're not returning anything. So there's no return statement. So if there's not going to be a return statement or there isn't, you can use void. You can think about to understand void, you can just think about when you're at Pick and Pay and you're shopping and then they call Prudence and they're like, Prudence, clear void. So you can think about that in that sense because nothing is happening. So that's why they're asking for a void because nothing is happening. They're trying to process the transaction, but nothing is happening. They're not getting back anything. They're not getting back anything. That's the important thing the point that I'm trying to raise. But here in this example, I'm getting back the maximum, that maximum value. So I'm going to do that. So let's check our maximum. So it's simple. I'm just going to say let's say I start with the first argument. We're going to go with the assumption that, let's say, for example, if the first argument, right? I'm going to say if the first argument or the first input is greater than the second input, what should happen? It should return the bigger input. The bigger input. Which one is the bigger input? It's A, because we've checked here if A is greater than B. So if A is greater than B, then return A. And then you're gonna have an else if You can use else too. It's up to you how you want to structure it, but I'm just going to use an else if. You're going to have an else if and say else if. So basically it means that this wasn't true. So else if it's like else check check another condition again. So what's the other condition that we want to check? If B happens to be the one that's now bigger, basically B, it references the second input or the second parameter. So if the second parameter happens to be bigger than the first parameter, we should return the value inside the value of the second parameter. So therefore, we found our maximum. So as you can see, this function, it returns an integer. I'm getting back something. So what's going to happen, right, when you use this keyword return, right, this return. So what's going to happen is that it's going to say, let's say the first argument, okay, let's say you call this function here. You've called the function, right? So let me just demonstrate quickly. So you've called this function like this, right? So what happens is that you're passing the first argument is 10, right? And you're going to reference it through A. So how are we going to reference it through A? So what is the computer, what is going to do? It's going to say int A is equals to 10. So that's what it's going to do behind the scenes. And then it will also say if int B is equals to 10 behind the scenes. So now A it is a placeholder for what 10. So this means that where there's A, I'm gonna have 10, and then where there's B, I'm gonna have I was supposed to make this 19. Where there's B, I'm gonna have 19. So it's going to check between the first parameter, which is 10, is 10 does 10 happens to be greater than 19? If it happens to be greater than 19, return 10. And then it's going to check again if B, and what is B? What value does B represent? It's 19. If 19, so I'm going to replace B with 19, is greater than A, what is the value of A? Or basically, what is the placeholder for A? What is the integer? Uh, what is A? What integer value is A placeholder for? It's 10. So I'm going to replace that with 10. So it's going to check if 19 is greater than 10, then return 19, because of course 19 is the one that's greater than 10. So that's what happens behind the scenes. So I just wanted to, so as you can see, return 19. So I'm getting back something. So let's say in this example, let's look at this example before I revert to the old code. Let's check here. Which number is bigger than the other? So if you check in this condition, right, is 10 greater than 19? No. So this is going to return false. And then it's going to skip this part because the condition was false. And then it goes to the next condition. Is 19 greater than 10? It is greater than 10. It's true. And then it's going to execute this part, the part that's within the if statement. Because remember, anything within an if statement or a while loop, it's executed only if the condition is true. So it's going to return what? 19. So what happens is that it finds a maximum and then returns that maximum. So in place of max, it's going to return 19. So that's what's going to happen. So that's why every time after using a function, we need to say, for example, int a is equals to that function if it returns something, because that function is going to return a value. So it's going to calculate, right? And then you said return 19, right? It's going to return 19. So in place of this whole statement, this whole line, it's going to replace that with the returned value. What's the returned value? It's 19. And then it's going to store 19 inside A. Then that's why you are able to say this and say, for example, max is, and then you display the maximum because you've stored the maximum inside a variable called A. Yeah, you can do something like that. So this is like the behind the scenes. So let's check it out now. Let's see what's going to happen. So I'm going to revert to the old code, return A, then this is B. If B is greater than A, then return B. Just a very simple if statement. So let's find a maximum between um 10 and 19. Obvious is going to um return 19. So I'm expecting 19 to be a maximum. So what I'm going to do, I'm going to say cout, and I've stored the maximum inside a variable called int max. Called sum max. I can just call it int max. Yeah, let's just make it simpler. So I'm going to say the maximum. I'm going to say the maximum between 10 and 19 is, and then I display that maximum. So int max. I've stored it inside a variable called int max. So let's see what maximum is going to output. 19. So the maximum between 10 and 19 is 19. Because remember, a function, if it returns something, it's going to return is that specific value. So what happened here is behind the scenes is that it returned that value, right? Remember, it's supposed to return the bigger value. Return B. What is B? If you check in this code, in my code, this ID, the ID that I'm using, it shows you the way you've named your parameters. So the first parameter is named A and it has a value of this. The second parameter is named B and it is a value of this. So it's going to return the value of B. What is the value of B is 19. So it's going to replace this with 19. That's why you're seeing 19 on the console. So we have that. We have a clear understanding of how functions operate. So we're gonna go back here and create the functions. So as you can see, it followed an input-output process. There's two parameters. These were the inputs. That's what was entering into the function. Those are inputs. And then the process is this code here between the curly braces. That's what the process is. And then the statement whereby you have a return, that's the output. Whenever you have a return, that's the output. So that's you getting the output. So return, it says get the output. So we're gonna do that. So let's create the functions, right? So the first function we're gonna need is the convert to integer function. So we have the necessary libraries, right? Okay, yeah, we do have. So I'm going to have convert, okay, conv to integer, which takes in a string str value. Okay, so it's complaining because I didn't specify which toolbox am I getting this tool from. Basically, I need to specify which namespace. Remember, namespaces are basically a way of sort of packaging all of our tools into one toolbox. So I need to specify which toolbox am I getting this tool from. It only makes sense. So basically, you can't go to a fridge and expect to get a horse. You can get a horse from a fridge because the fridge is not the toolbox for horses. So that's not where you get those tools. So it's the same thing. So you need to specify where you are getting it, and the toolbox that you're specifying, it needs to make sense. It needs to have that tool that you're currently looking for. So I'm going to specify it by saying standard, which is the name of the toolbox, and then two colons like this to say within this toolbox, take this tool. That's all I'm doing there. And then we're gonna have a function to create our world, right? So I'm gonna have, in this function, right? Remember that we have a record structure. Remember what I said about a record structure. A record structure represents an entity. It can be a person, a civilian, an employee, a manager, any entity, anything that you want to represent. It can be information about a building. So it basically, in a way, we're basically packaging information related to one entity. That's a record structure. So what's the information related to a game? It's a two-dimensional array. There's rows, the number of stairwells, and the number of fuses. So I'm going to create the functions now and stop wasting time. So I'm going to create the function. Remember the function, um, uh, the way you declare it, the syntax is you type in the return type first, space, and then name of the function, right? And then semicolon, because we are in the header file. The header file, you're only declaring, you're only saying, you're only telling the computer that listen here, I'm gonna make use of these tools. I'm gonna define them. I'm gonna show you, I'm gonna tell you how they should be used. What do they do, these tools, later on. But for now, just know I'm gonna make use of these tools. And I'm packaging it inside a toolbox in a namespace. So we have that. So name, and then we're gonna have our parameters here, of which the first thing that you type is the data type space name of parameter. You're gonna have the name of the parameter, and then you're gonna keep repeating that and have as many inputs as you want. So let's do that. Let's create the function. What are we getting back? We want to get back a game. So I want to get back something that represents my game. What is something that represents my game in the following code? It's the record structure. That's what represents my game. It's the record structure called game. So the return type for this function, I'm going to get back a game. And then I'm going to call it create world because it's a function that creates my world. And then this function is going to take in all of the things that we get from the user, which is the size of the game world and the number of stairwells and fuses. So let's do that. So I'm going to take in the number of rows and take in the number of columns and take in and what did I call it? Int num stairwells. So int num stairwells, and then I'm going to take in int num fuses. So that's what I'm going to take in. These are my inputs into this function. So basically you can view it like this. It's like some sort of function just like f of x, you can say f of x is equals to, for example, x to the power x squared plus 1. This is a function, right? And whatever is in between the brackets is what we call the input into the function. So that basically means that if I were to input between these brackets and say 1, it means that here it's going to change to a 1. So that it becomes 1 squared, which is 1 plus 1, which just gives me back a 2. So it follows the same approach as in maths. So you can view it like this. You can view it as like the first part being int rows, and then second part being int calls, and then third part being int num stairwells, then the last part being int num fuses. But okay, just for now, remember this part, we're gonna define it in the CPP file. So we're just gonna leave it like this. And in C++, the syntax is that you need to specify that you've reached the end of a statement or a line of code, you put a semicolon. So that's why I put a semicolon there to say, okay, my function ends there. So stop there. Don't look for any other definition for this function or any other information. There's no more information coming after this. So I'm going to put a semicolon, which is equivalent to putting a full stop in a sentence when you're writing an essay. So it's equivalent to doing that. And then in place of f, it's this name of the function. It's going to be what? Create world, right? And the way computers work, like I said, you need to be explicit. You need to specify what type of data each input stores. So all of these things, the int columns, int rows, int stairwells, you need to specify what type of data they take in. So that's where ints come in place because I'm taking in integers. So you're gonna take in all of those things, and you need to specify what's going to be returned, going to return a game. So that's why I had this function in this format. So now we are quite familiar with how functions work. So let's create a print world function, right? Print world function, which takes in my game, and it's a record structure. So I'm going to use the prefix rec so that I remember that it's a record structure. So rec world like this. It's complaining because I didn't specify a return type. Remember this, the syntax for declaring a function, you start with the return type. So what calculations will this function do? Is it doing anything? No, it's not doing anything. So I'm going to use that keyword. That's it. This is where I'm going to need prudence now here to say curly void. Yeah, it's not going to return anything. So this is where void comes into action. So I'm going to need another function for deallocating. So de dealloc. Yeah, I'm going to call it dealloc to deallocate. And then I'm going to rephrase this now. Yeah, I'm just going to call this alloc. Yeah, I'm just going to use a different approach, different way of naming things. So I'm deallocating, right? So what am I deallocating? I'm deallocating the game. And what's the thing that represents my game? It's this record structure. So I'm gonna take in that record structure. So I'm gonna take in some record structure. Let's say it's called record, right? But remember, whatever input you take in into this function, you need to specify that it's the type of data, the type of data of its contents. So what is it? What type of data is it storing? You need to specify, is it storing numbers, is it storing characters, is it storing strings, integers, floats? You need to specify. So what is it storing? It's storing a type of a game. Remember the record structure name, it acts as a data type because we've defined some structure, also yeah, anyway, we've defined a structure. I don't know how to really to put it in a easy to understand way, but yeah, we talked about structures. It's just structure, just creating you're just creating a link. Um, you're just creating you're storing information based on that one entity. For example, in our application, the entity is a game, and this is the information that we want to store for each game. So I have that. It's complaining because I didn't specify what I'm returning. So am I getting back anything here? No, I'm not getting back anything. So I'm gonna use void. I'm not getting back anything. So basically it is doing the input process part, but not the output. So if it's not doing the output part, so basically there's no return, there's not gonna be a return statement here. I'm gonna need a void. I won't need to specify the data type, the return type as a data type because there's nothing that I'm returning. And remember, this is a dealloc. You are deallocating. You're making what changes to that specific entity. In this case, it's the entities we called it game. So if you want to make changes to something, you pass it by address. So let's talk about this address. This address might look might be something that looks quite peculiar, but it's fairly straightforward. So the reason why I'm gonna pass it by address, right, is because you there's two ways to the way you can change in information inside the placeholder is by going to its address. So you can imagine a computer, right? There's like, bookshelves, right? So the computer is like that. So every time you create a variable, it has a specific bookshelf that it goes and stores that variable at. So it stores it at that bookshelf. And each bookshelf, it has an address. So that's why we need to make use of addresses so that we can go to that specific bookshelf and remove the contents of that um, bookshelf. But by contents, it's we are removing what's there. So we go there and remove what's there by using the address. So I need to go to that where this variable is located. That's what the address is for. The address of operator, this is what we call an address of operator. Basically, it's an operator that finds what an address of something. That's what it means. So we're gonna use that in a way to find the address of a specific variable and then change its contents. So change what is contained within that variable because, like we said, each variable it's like it has its own specific bookshelf. So it can be something like this. So let me see. Okay, no. Okay, so it's going to be like this. Let me try to visualize it. And then here at the top, I'm gonna have, so as you can see, so you can view this as like our bookshelves, right? This is like our bookshelves. This is what I was talking about. So what happens in a computer, right, is that when you create a variable, so let's say you say int a is equals to 100, it automatically generates an address to store this variable. So it generates an address to store a variable. So each bookshelf, the way the address starts, right? It always starts with an O of X, 0x like this. Yeah, we don't have to go into details about that, but yeah, you're gonna learn it in computer science 1B. So it's gonna talk about this. So it stores in addresses like this. So let's say, for example, the address, the formula that we're gonna use, and then here there's gonna be some specific formula here that we're gonna use. So what formula I'm going to use? I'm going to say distinguish each address by an integer. I started one. Whenever I add something, whenever I move to the next shelf, I say plus one so that it counts, it adds a one. So I'm going to say 1, 2, 3, 4, just to basically say that this is the first shelf, this is the second shelf, third shelf, and then fourth shelf. So let's see. What happens is that now you have this. This is the variable, right? 100. Okay, we stored 100, and then there's the variable. We've created a variable. So it chooses one of them. Let's just say it chooses randomly, right? So let's say it's going to come here and store randomly in bookshelf number one. So there's our variable. It's stored inside bookshelf number one. So we have two things. We have the variable itself and its address. So we can find where a variable is stored because that's how a computer operates. That's how it's able to keep track of things. That's why you're able to do something like this. And let me see. Let me say view. I want to exit this full screen so that I can demonstrate. So that's why it's able to remember. For example, if you say, okay, let me say, if you say, let me click here, my file explorer. So that's why it's able to remember the things that you have. If you click here and you go here, you see it gives me a list of my files because everything is stored with an address. If I go inside this PC and then I come here, you can see things here, my folders, everything. How does it remember all of this? Everything has its own specific address. Remember that a computer operates the same way as our it works, it has the same formula as the formula that we have on Earth. So remember, each person stays at a what? at a house, you can view this as the house. The shelf is like a house, and each house is a what? It has an address. So, and each house, it has what? Someone staying there, of which is a variable. So that's how it works. So it always has a specific structure. So that's why I need to say, if I want to make permanent changes to this, how do I do that? I go to this address, and then after going to this address, I replace this, whatever the content. Remember, it's just A is just a placeholder. So basically what's actually being stored there, it's 100. Remember A is just placeholder for 100. So what's actually stored there is 100. So if I want to make permanent changes for that variable A, I'm gonna go to this address, get the address, and then make the changes. So let's say I want to update it to 30, it's going to update to 30, like that. So that's very important. Understanding this information is very important. They're going to teach you in second semester, and you're going to do it in computer science 3B2. Yeah, it's very important information. Just the fundamentals of how things are stored in computers and things like that, so that you can understand why I need to pass by address. For example, you can't say, okay, you're gonna kick someone out of their house without knowing where they stay, right? So you need to know where that person stays in order for you to make permanent changes. What are those permanent changes? You want to kick them out. So that's basically what happens behind the scenes. We want to update that value at that location. So we need to find the location. We need to find the address. So I can also show you here proof that this is true. Remember what we were talking about, that each variable is going to be stored in its own specific shelf, and each shelf it has an address, right? So let's do that. Let's do that. So let's print the address, right? And we can use that, yeah, using a different language. So we can print the address of that variable, right? How do we do that? You say address of what? Of A. That's the variable. I want the address. And then I'm gonna have an end of line character. And then I'm gonna run. There's the address. What did I say about 0x? It always begins with 0x. Then there's some specific formula there. There's some specific formula. And this address, right? It makes sense that there's rules, even in our world on Earth, we have rules of naming an address, right? I it always starts with a street number. That's how it always starts with that. So street number, it's equivalent to you saying O of X. It always starts with 0x. It always starts with 0x. And then it's followed by the other information depending on the formula that's being used, and then there it is. Let's create another variable, int b, right, is equals to 30, like this, and then let's output the address of b, and line character. You see it's going to begin with 0x. As you can see, it begins with 0x. I know you might think that they look similar, but they're not. You see, at the end, you see there's a C there, there's an 8 there. It's not the same location. But the important thing is what it begins with 0x. So it's in that specific shelf. This one is in its own specific shelf. And we can make changes by referring to that specific address. So that's very important. You need to keep that in mind. So now we're gonna use pointers, right? So let me create a point. So I'm gonna have int pointer variable a, right? That's the variable. And then I'm gonna give it an initial value, right? So I think, yeah, you can do this. Yeah, let me see. Okay, let's see. Wait, why do I keep doing this? So let me see. Let me test something here. So with the pointer, right? Yeah, okay, with the pointer, remember that the difference between a pointer and a variable if I say C out and I say okay, this is B, and I say B, C out B, right? Like this in line, it's only gonna output what? The value. So because a variable, it only stores one thing at a time, but I can find its address by using the address of operator. The beauty with pointers is that it stores two things at the same time. You can reference the actual value and you can get the address of that variable. That's the nice thing about a pointer. There's two things that you can get, its value and its location. You know what the value is, you know where it's located. So let's just test it out now. So to find its address, right? Remember when you declare it, it's int pointer. So basically it's like this. This is the name of the verb. It's pointer A. So if you want to get the address, you you only output it without the asterisk, without the pointer. So I'm only going to output A. A stores the address. And then the pointer, it means go to that address. So A stores that address that goes like this. And then the pointer, this, it means point to the address. So basically point to the address or go to the address. That's what the pointer means. It's point to the address or go to the address. That's what it means. What's the address? The address is always next to that pointer, as you can see. That's why I declared like this, so that you can get the value. So that's how you can get the value. This, when you say int pointer, this is the value itself because now you've pointed to this address. And then if it's just A, what do you have? It's the address. It's just the address. That's very important information. So that's why here, when I want to output the address, I only output A. So let's do that. As you can see, yeah, as you can see, you see the differences between the two. Look at B. It's not displaying B, right? It's not displaying an address, it's displaying a value. So let me just initialize it to 100 so that you actually see what I'm saying. As you can see, when I say C out B, what am I getting? A value, because variables only store one thing, the value at a time. It only stores a value. And then with pointers, it stores both an address and a value. You see, this is the address. This is how you reference it. And then you can point to an address like this and get the value that's at that address. And then it displays. The thing is, I haven't given it a default value, so it has some junk. This is junk right here, negative 40 something. That's junk. But as you can see, you saw that it actually got the value. So point is means to point to that address. Go to that address. That's what it means. As for B, it doesn't store the address, so I need to find this clever way to get it. I say get the address. That's how I'm going to do it. That's the clever way of doing it. And then this, it's no longer that. We're only displaying addresses, remember? So it's like this. Then B, okay, I don't know why it's doing that. It should be displaying. Yeah, I don't know why it's doing this. Okay, let me do this. Okay, I don't know why it's doing that, but yeah, just know that A, it stores the address, that the name without the pointer, it's the address. When you combine the two, the pointer and the name, it's the value. So let me show you a quick way on how to update the value at that specific address. The first way, right? You can change addresses, which is basically moving to that address. That's how you can do it. How do I move to that address? Let's see. I just say A. Remember, A is the address. So what do I want to do with the address? I use the assignment operator. I'm assigning a new value to my variable that stores the address. What value am I assigning it? I'm assigning it an address of B. That's what I'm assigning it. I'm going to extract an address of B. Remember, B is just a variable. It doesn't store the address. I would have to find a clever way to get its address. And I do that by using the address of operator. So it's going to get the address and then it stores it into A. So A has been updated. So A has basically moved to a different location. That's the first approach to change the value. There it is. So this is the address of B. This is definitely the address of B. So let's just do this so that you see. So these two things need to be equal. So let's see. There we go. They're exactly identical because I've updated the address of A and stored and took the address of B. So what happens is that once you've updated, what does it mean? You've relocated. So if you move into a house, what happens? You automatically have whatever's in that house. So if there's a kitchen unit, there's a bedroom, there's a shower, all of that is yours because you've moved to that address, you've moved to that location. So now if I want to print the value, let's say I point to that address, what value should be displayed? It's the value it's the value that's there at that address. What's the value that's there at address of B? It's 100. So it should output 100. There it is. There's 100. So that's another way of that's another way of updating the value. To show you that it actually updated, let's create two variables. Let me have C here is equals to 900, right? So it starts off as this, right? Because I need to give it a default value. So remember, it has junk by default. So I need to assign a default value. The default value is going to be 100. That's the default value, right? And then here, instead of outputting this, I'm going to output before. So it was before changing address. It's going to output this. And then after, it's going to be an after. And then now I'm going to update the current address of A. Remember that the approach we're using to change the value is the address. Current address of A is equals to a new address. What address do I want? Address of C. So now it's going to, for the value of A is going to take the value of C. Because whatever C has, I now have it because I've moved to that address of where C is located. So let's do this. Let's run it. There we go. Perfect. There it is. So before I will give it a default value, before it was 100, right? That was the default value. And then I relocated. But wait, how come it knows that now the new value is 900? Why is it taking the value of C? Because you've relocated to that location. Once you automatically relocate to that location, you have everything that you found there. It went there and it found a value which is 900. So now it automatically also has that value. So that's how you can update. That's how you can make permanent changes. But let's see, let's try to use the other approach, right? This is the approach for permanent changes, right? Permanent changes, right? So let's try the other approach, but I'm gonna comment this out because I want to try the other approach, right? So let's say I point to the value itself and then I update the value itself. That's what I'm trying to accomplish, right? Remember, this is point, it means go to, basically means go to, and then A is an address. So go to what? 0, what? So it's going to get back the value. That's what's happening there. But instead of me writing all of this, all I do is just say pointer, point to A. A is the address. And then here I'm going to say the new value is um something like this. This is a new value. So after here, it should display what? This value, because technically I've updated, right? Let's see if it did update. Well, okay, it does update. Okay, yeah, it does update. Yeah, my bad. Yeah, this is the second way. Yeah, it's only updating because I have a default value. Because I remember, if you don't have a default value, a starting value, this won't work. This line of code, it won't work at all. It it's not gonna work. So you need to have a default value first. So, but yeah, it does work. So this is the second approach of changing the value. So yeah, there's two ways of changing a value in pointers. Why am I saying pointers? Because remember we have a two-dimensional array of pointers. So we're making use of pointers. So we need to understand how pointers work. So we understand how pointers work now. So I'm gonna remove all of this. And then let's continue with our functions. So that's why I need to pass it by address because I want to make permanent changes. And I can't, as you can see, it's a problem. I could have passed it like this and say pointer, right? That value. Pass it like that because you can also make those changes like this. We saw that you can make those changes. You can make those changes, but I'm just gonna put address off because address off it's the only option that I have, to be honest, because I can't. This is within a record structure. So the best thing I can do is just say take that record structure by address. So that means whatever changes I make, they're going to be permanent. So there's my functions. So now it's time to implement. So let's come here and implement, paste them there. And then since I'm going to be implementing here, I'm going to have a lot of code. So I'm going to need to say using namespace standard. And then you replace the semicolons with what? Curly braces. Because now you're providing implementation for each of the functions. So let's do that. So let's see. Let me double check how far it is. Okay, it's 53 minutes. Let's do time. I don't want to make it I don't want it to be too long, but yeah, I'll try to stick within hour and a half and to an hour, somewhere there. 2 hours, I mean, somewhere there. So, but yeah, I don't want it to reach 2 hours because I know the student mentality. You're gonna see this recording and be like, yo, 2 hours, I'm not gonna do that. That's too long. So the first thing that I'm gonna need a function that generates a random integer. Because in our game, to be honest, if you check, we are using integers. If you check, it's integers everywhere. Integer, integer, integer. If you check here, if you check here, type def int pointer point, it's integers. So that's why I'm creating a function that generates a random integer. So I'm gonna call it random. Yeah, I'm just gonna make it very simple. Random. It's a random value. It's gonna take in two inputs, which is a starting point. Okay, I got starting point, and then int a stopping point. So we have that. And remember with a random generation, a random function is that we make use of the rand function, which randomizes, gives you a random integer. But when you leave it like this, the integer is going to be, okay, there's a function that I forgot here before you continue. The check range. Yeah, we need to have that function, a function that checks the range. So I'm gonna have check range it takes in a value, int value, the value that we want to check, and the ranges that we want to check it from. So I'm gonna have int min and then int max like that. And then I'm gonna have void because all it's doing is just checking. And then we're gonna have this there. There we go. And then there's something that I want to add. It's the constant, the max size. It's a constant that we're going to use to compare when you use the check range function. We're gonna say if that is it's some maximum. We're gonna say if the input happens to exceed this maximum, this max size, we're gonna define our own max size, then do something. So the way I'm gonna remember it's a constant, right? So const int, and I'm not gonna have a collection of them, right? It's only one. I'm not gonna have a collection. So don't don't think don't ask yourself about don't ask yourself why am I not using an enum. A enum, it's only when you have a collection and it's related to one to something. It's an entity or whatever you want to call it. Or yeah. So we're not gonna do that. It's only one thing. There's no need for me to create an enum for it. So I'm just gonna create a const. It is just a normal constant. So const int max size. We're gonna define some max size, right? And then I'm gonna say, um, okay, I think you can say int 32, 62 max, right? Okay, okay, I know it kind of it's kind of weird the way this thing you've never seen it before, but all I'm doing is just I'm getting the maximum, basically the maximum an integer can store. So that's all I'm displaying there. So let me do this. Let's display and find out what's the maximum that an integer can store. Okay. Okay, this part is complaining. Yeah. So this is the maximum value that it can store. You can see, right? That's the maximum that it can store. So int64 just means integer for 64-bit operating systems. I'm using a 64-bit, right? So I'm using a 64-bit, so that's why I'm going to use this one, this value. If you're using a 32-bit, you can just say int32 underscore max. This is the maximum for a 32-bit operating system. So we're gonna use that as let's see. You can also do this. You can do this hash if and def like this, right? And say if it is a Linux or a 32-bit system, is it no, it's 64-bit. If it's a 64-bit system, then here you can just do something, right? So for example, you want to create, you just want to create a constant for a 64-bit system, right? So constant like this, if it's 64, create a constant using int64, because I know if it's Linux, it's going to be 64-bit. And then you're gonna have hash elif and def. I think it's elif and def, yeah. And then you're gonna have win 32. But if you want to, you can be specific and say win 64 like this. To say 64-bit, you can do that. And then here, I'm not sure. I think there's something that I'm missing, but let's see. And then here you have that. And then here you're gonna have an end if like this. I think so. I tend to forget the structure, but yeah. So you can define something like this. You can say if it's 64-bit, define a constant that's of size 64. If it's 32, define a constant of size 32, like this. So let me see. I think, is it elif def? Yeah, I think it's elif def. And then this is going to be if def. Okay, I'm not sure. It's kind of confusing. I've never really used this. I've never really used this. Okay, yeah, you need to end it. Yeah, I've never really used it, but yeah, you can do it like this. You can say Win3064 and Win32 to say Windows operating system, 64-bit Windows operating system, or Win32 for 32-bit operating Windows system. But we won't get into that too much detail. We're just gonna leave it like this. I'm using 64-bit, so it's gonna work on for my for my computer. It's gonna work on mine. You can check your computer details by just saying about your PC, like this. You just search about your PC and then you're gonna see. As you can see, mine is 64-bit, 64-bit operating system. So we have that. Yeah, I just wanted to create that. Yeah, it took too much time, but yeah, I have this max size, right? That max size. So what I'm going to do is I'm going to generate a random integer, right? A random value. So the way you generate a random integer, I'm gonna go through it again. You take this function, right? Remember, it's going to generate infinite number of values. There's no range. It's not restricted. So we're going to restrict this to give us a value within the right range. And we're going to use the modulus operator. So this is how you do it. You're going to say modulus modded by the number of values that you want generated, and then plus the starting point for those random values. So what's the exact value? When you say plus, it's the exact value that it needs to start generating from. And then modded by the number of which we call it the range, but in essence it's just the number of values that you want to generate randomly. How do you calculate the range? Just gonna say int it's going to be the starting point minus the stopping point, which is going to give you some answer. And then it's going to be short by 1. It's going to be off by 1. So you need to add back a 1 in order to get the accurate range. But why am I saying it's this formula? Let's test it out. So if you wanted to generate, let's say, values between 1 and 8. Okay, let me say 1 and 4. Let me just make it short. 1 and 4. How would you find the range? Okay, how many values? Let's start with that. How many values would this, how many possibilities do I have? How many values can I possibly generate? And remember that it's inclusive, both 1 and 4. It's inclusive. So I'm going to say 1, 2, 3, 4. So I can generate how many values? 4 integer values. If I apply this formula, just this formula, I won't apply this plus 1. I'll just apply this formula for just subtracting. So what's my maximum? It's 4. That's just no, it's yeah, I made it declared it wrong. So it's stop minus start. So what's my maximum? It's 4. So it's going to be 4 minus my minimum, which is my starting point, which is 1. So 1, which is going to give me 3. But is it 4 values? Is 3 equals to 4? No, it's not. It's off by what? By 1. So 1 is going to give me 4. So that's why I always add that 1 back to the answer that we get because it's going to be short by 1. It's going to be missing a 1. So let's do that. Let's find the range. So int calculate range. I'm going to store it inside int range. It's equals to int stopping point basically our maximum, minus int start, our minimum, plus 1. And then I'm going to use the keyword return to say that I'm getting back. Remember that it's getting back an integer. So I'm going to use the keyword return because I need to keep need to keep my promise here, because this is when you say you're going to return an int, listen to the statement. You are going to return. So you are promising that you're going to give back something. So you need to use the keyword return and give back that thing that you promised. So let's do that. So it's modded by the range or the number of values. It's this, and then plus the starting point. So it's going to be plus int start. And then there we go. We have a random function. We are sorted. So let's look at the convert to integer. So with convert to integer, you're gonna create a string stream, right? String stream. String stream is just basically a stream of strings. So you can imagine this is the stream. It's just some, it's just like wool. You can imagine that this is wool. This is just the stream of strings, right? And you can add a string into here, right? Let's say I want to add go. That's the string that I want to add. You can add a string called go. So it's like that. That's the string. And then you can take it out. You can take out that string by replacing that go with empty. Yeah, you can take it out. Just do it like that. Take it out, and then it becomes empty again. So it's called a stream of strings because, as you can see, what does it look like? It looks like a stream. And it's gonna be a stream of what? Of strings. Not characters per se, but it's strings. Even though even though you see it's dotted, but it's not characters. It's not gonna be like I'm gonna have an A there and then I'm gonna have a C there. No, it's gonna be a string. Even, yeah, I know you might be like, okay, but yeah, technically it's an array of characters. Yeah, it is, because a string in essence is just an array of characters. It's still fine, but yeah, this is the approach. So the first thing that we're going to do is the string stream, right? So let me show you how it works. So the first thing we're going to input into the string stream. How do we do that? So I'm just going to write this code, str value. So what happens is that you see where the arrows are pointing. They're pointing to the left-hand side. So this is just a placeholder. Remember what it did when it doing the maximum function. So this is just a placeholder. So here it's going to replace this with the actual value. Let's say the value is 78, right? So it's going to take 78. Remember, look at where the arrows are pointing. So this, the one that's on the right-hand side, is going to go into the string stream. So what happens is that it's going to come here and then start pushing the 78. So it's going to be like this. So now you have a 78 inside the string stream, the stream of strings. That's where the 78 is currently stored. You've taken it and stored it inside the string stream. This is the first part, this line. You're storing the input or the string into the string stream. And then now you're getting it back. So you're going to get it back. And then remember, this function is to return an integer. So I'm going to create a local variable. I'm calling it local because it only exists between these two curly braces. This one, the starting point, and this. This is where int value exists. It's local. It's only local. So now I'm gonna take back what I've stored inside string string, this 78, right? And put it into what? Int value. So now it's going to open. You can say maybe this is the gate, right? Something like that. You can have, okay, let's say this is like the gate, right? This is like a gate. So now when I get to this part, when I want to take it from the string stream, it's going to open the gate, and then it's going to take this and then put it inside int value like that. And then it's gonna close. It's gonna leave it the way it's gonna leave it the way it found it. So now int value has the integer value 78. But before, in the process of doing this, of storing, of taking from the string stream, it needs to convert, it needs to compare, it needs to check if, so it needs to check if what I have here in the string stream, this 78, is the same type, as int value. It's going to check. If it's not, then it's going to convert this to be this type. So remember, it's a string stream. Even though it's 78, it's inside the string stream. So the data type is a string. And then this, the integer is a what? The int value, it's an int. So as you can see, I have two incompatible types. So it's going to convert this to be an integer before it stores it inside int value. So that's what's happening behind the scenes. So it takes from here and then stores it into there. So I'm going to check if it has failed to do that, to convert, because when it takes it from the string stream, it's going to convert. Oh, okay. I knew I was forgetting something. Okay, I do have it. Okay, I thought I forgot it. So I'm going to use this status code error in converting to int to exit. So I'm going to output C error, and then I'm going to specify what I failed to convert. What did I fail? I failed to convert this string. Failed to convert to, and then I failed to convert to what? Integer. Yeah, I'm supposed to say integer here. To integer. And then end of line character. And then I'm going to exit the application. And then I'm going to put in a status code there that I'm going to remember, which is error in converting to int. And then once I'm done, if this happens to be, if this part doesn't execute, that means what? My application won't exit, because it only executes if the condition is true. If it has failed to convert, that's the only time it's going to execute. And then I'm going to get back int value, the integer that I've converted, and then I'm done. So now let's allocate our array. The same thing with the other functions. It has to return. So I'm going to create a local variable of that type, the return type of the function. What's the return type? It's game. And then I'm going to give it a name and call it rec world. Before I do anything, I'm going to return rec world. And once you do it like this, when you have a variable of which the data type is the same name as the name of the record structure, what happens is that now you can access the members or the information within this record structure. I can access the array world, the two-dimensional array world. I can access the rows, the columns, the stairwells, and the number of fuses. I can access all of those things. So let's do that. So we need to store all of this first. All of this. We need to store it inside the record structure before we make any changes. So record dot, as you can see, starts suggesting me the variables that are inside. In each variable that stores each information for each game. So it's going to be int rows, and then record dot int columns is equals to int calls, and then record dot int num stairwells is equals to int num stairwells, and then record dot int num fuses is equals to int num fuses. There we go. We've stored everything, all the information regarding that one game. So we have that, we are done. So now we need to allocate. There's one thing that we haven't stored for. It's this. This is a bit complicated because did I include the CR set? Okay, I didn't include it. Yeah, the two-dimensional array is a bit complicated. Remember, it's a two-dimensional array. So the first thing I need to do is allocate memory before I can give it a default value. So I need to say dot array world, right? And then I say is equals to new int. Remember, it's int pointer pointer like this, right? So you're gonna start with the first pointer, which is the closest one, the one at the end, like this one. You're gonna replace it with square brackets to say that I'm allocating for this pointer. Because remember, a pointer is equivalent to a dimension. So each pointer represents each dimension. So when you want to specify the size of that dimension, what we're going to do is we're going to replace the pointer with square brackets. So replace this pointer with square brackets and say the first dimension is going to be a dimension of int rows. And then I'm going to go through all of the rows. Int r is equals to 0. R is less than int rows. Then r plus plus. I have this. And then now I'm going to go through each row because remember what we said in the previous in part one, tutorial in part one. We said that the way it works, like the way a game works, is like this. You have all of this, and then you're gonna have the necessary features like this. So by default, it's like this. But when it's one dimensional, it's like that. So in order to make it two dimensional, that means what you do is that you go to the one dimensional array, and then at each index or each position, you allocate a whole array. So that's what I'm doing. I'm going to allocate a whole array at every single index. Every single index like this, a whole array. And the first dimension is going to be what? Our rows. So that's why I'm going through the rows. So let me allocate. So I'm going to say rec world dot array world square brackets row r. Remember, r is the current row. Why am I saying current row? Because I'm going through the number of rows. And then I'm going to say is equals to new int again, because remember we haven't allocated for this. So that's what we're doing right now. I'm allocating for the columns, right? Basically the columns, yeah, the columns dimension. So now I'm only left with this. Once I've used this, I don't need to use it again. It's no longer there. I've replaced the pointer with a size with the I've allocated the size for that dimension. So now I need to allocate the size for the next dimension, which is the last one, this pointer. So how do we allocate? You replace the pointer with square brackets like this, and then you specify its size inside the square brackets. It's int calls. So I've allocated for my game world. So now we're gonna need default features. So let me see. So the thing that I'm going to do right now, right? What I'm going to do, right? I think I'm gonna have two arrays. But yeah, if I make two arrays, um, yeah, I don't want it to be too complicated. Let's see. That because there are two environments, that's the thing. Ugh. There are two environments. There's the ground floor and the basement. And they seem to be, yeah, they are linked to some extent. They are linked. Yeah, they are linked. So I'm not sure about that, how we're gonna tackle that, but we're gonna get back to that part, to the logical part, once we are done with the basics of making a game. So I've allocated, right? But wait, I think it might be very important to just get it out of the way. Player may be holding a torch and any number of fuses. It starts in a random column. The torch cabinet appears in a random column location in the last three rows. Um, Wait, there's something that I'm not getting here. The player may occupy the same while the player does So while the player does so, may climb the stairs as a movement option. Yeah, there's two arrays here. Yeah, definitely gonna need two arrays. And they're of the same size. Yeah. If you check here, there are two environments of the same size. So inside my, okay, they said there's first floor and second floor, right? That's what that's how we approached it. Second story and first story. So what I'm going to do is I'm going to create another two-dimensional array here, 2D array. And then I'm going to call this one second story. So this is the array for the second story. And then this one's going to be the array for the first story. Right. And then this is going to be first story. And then second story. Like this. Right. And then now what I'm going to need is, okay, let's see. Okay, yeah, this is fine. So I need to repeat the same process and allocate for this thing and allocate for the other story. So I'm gonna have uh second story. Okay, this is supposed to be first story here, not second. First story, then second story is there. And then there we go, that's fine. So I'm gonna allocate for both the arrays because it has two environments. So I'm gonna need two arrays. So now we're gonna need to start placing. Let's see. So now I'm gonna need the normal for loop here that goes through every single column because now I have a column I've allocated. Where did I allocate it? Here. So I'm gonna do that and then say less than int columns C++. Then I do the very same thing here for the second story. I only allocate features for the second story inside the second story array and features for the first story inside the first story array. So let's do that. So yeah, we definitely gonna do the placing world. This first initialization, we're gonna finish it in this session. So the initialization, and then in the next session, we'll take it from movement. And then after movement, we just do this success. And then we'll be done. So let's see. The fuse box appears in a random collection at least 3 squares away from the edges of the game world. It is surrounded by walls on 5 sides per the image. So let's look at the fuse box. The fuse box is the star. So it's surrounded by how many stars? 5 of them. Which makes sense because if you check here, if you zoom in, this square is 1, and then this square, okay, if you check this square is 2, and then if you check this square, this one is 3, and then if you check this square, it's 4, and then if you check this square again, it's 5. So it is 5 squares around. So we're gonna come up with the logic for that. That won't be a problem. We're just gonna break it down into a very simple thing because it is a simple thing. Just need to understand the basics of it. So it's at least 3 squares away from the edges. By 3 squares away, it's 1, 2, 3. So it's at least three squares away from the edges. So these edges, at least 3 squares. And it seems like for this one, they were not even. let me see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, they were not odd. Yeah, if they're odd, it's easier to divide exactly from both sides and separate it. It's easy to do that. So the way it is now, it's at least 3 squares, right? Okay, it's the fuse box. Okay, we don't have to worry about the other things. So it's placed at least 3 squares away from the edges. So that means in terms of our rows, okay, the rows is fine. The important thing is the columns, the range. So the range of the columns is going to be at least 3 squares. So remember when you start counting, right? You're going to start counting at 0. This is 0. This is going to be 0 here. And then this next block is 1. Then the next block is 2. And this is 3. This is 4. This is 5. This is 6. And then this is 7. So you see, even though I have 8 columns, I stop at 7, which is the number before 8. So what is the previous? How do I get this one? How do I get 6? I subtract 1 from 7. How do I get this one? I subtract 1 from 6. That's how I get 5. So that's how I can get the 3 blocks away approach. So, and it's placed randomly, right? In a random location, at least 3 squares away from the edges. So I think even the rows, yeah, okay. For the rows, it seems like it doesn't matter. As you can see, it's 1, 2, 3. Okay, we'll try to place it at least. Okay, this is what he said. This is the first story, right? Let me double check. First story, it has the fuse box, right? Yeah, the first story has a fuse box. So I have this. So let's see. I need to remember how you place again. So I'm going to do this. I'm going to create 2 variables, right? Int r, int row. I'm going to start at 0. Then int column. Okay, let's use the proper naming conversion. Then I'm going to say int row. Proper naming convention. So let's do that. So I'm going to have that. I'm going to say int row, right? Generate a random value between the starting point, which is, it needs to be at least it needs to be at least three spaces away from 3 squares from the edges. So 3 squares from the edges, if you check here, if you check in our code, if I start counting from here and I want to get to 3, which is this one, there it is here. It's 3, right? So how did I get to 3? If I start counting from here, that means I say it's 0 plus 1 plus it's 0 plus 1, which is 1, and then 1 plus 1, which is 2. 2 plus 1, which is 3. So you see, I start counting at 3, so I need to add 3. Oh, basically, I need to start at 3. Usually, you start at 0, right? And say 0 to that. But now I'm going to start at 3 because it's at least 3 squares away from the edges. And it is inclusive because if you check here, what is its exact uh, uh, if you check how many squares away is it, what is its exact column? I mean, it's in column what? It's in column. It's in column. Let me see. It's in column 3. I mean, it's in column 3. So we're gonna do that for both the rows and the columns. And then for the upper bound, the stopping point, it's going to be int rows minus 3. because I need to move three squares away from the edges. So it's going to be 1, 2, 3. And then I can place it within, so it's this 3. So if you check, it's this 3, right? Edges away from, and then this 3. So that means I can only place it within, I can play around within this range. So I'm gonna do that. So if you check how many squares is it away? Remember, this is -1. It's already -1 here. I subtract another one, so this becomes -2. I subtract another -1. When I'm here, it becomes a -3. And then when I get to here, the actual row that I want, because now I have 3 squares here. So when I get to here, this part, what is it? It's -4. So I'm going to say int rows -4, like that. And then I'm going to do the same thing for the column and say random. Oh, before we do this, um, okay, yeah, this is not, it shouldn't be in here. I don't know why I'm doing this. Remember that the first story, by default, the game mode is going to have empty spaces, right? I forgot to do that. So first story, what is the empty space? It's empty square, right? Empty square. There we go. And then for this one, it's a what? So it's going to be record dot second story RC is equals to it's just blue box, blue what? Blue squares, right? Blue gray squares. What did I call it? Don't tell me that I didn't put it. Yeah, seems like I didn't put it. Because I have empty square here. I have a player, fuse, touch cabinet, darkness, fuse box, walls, stairwells. Forgot to put it. Let me see, index 4. I did put it here. So how many things do I have? I have 8, right? Do I have 8 in here? It's 1, 2, 3, 4, 5, 6, 7, 8. Or maybe I called it walls. Let me see. What's the other name? Oh, it's darkness. It's called darkness. I totally forgot about that. It's called darkness. So I'm going to say darkness, no, darkness. Darkness represents the second story. That's the second story. So we have that. And then after all of this is done, the placing the default ones, I'm gonna have this. I'm gonna have the random generator, right? Generate between int calls -4. There we go. And then now I'm going to, okay. Is there a need for me to check? Because, yeah, there's no need for me to check yet because I haven't placed any. If you check here, I haven't placed any feature in my world, like the important features. For now, all I have is an empty space. So I can replace an empty space. And then it says that it's surrounded by 5 walls per image. We're gonna need to also take that into account. And highlight in pink so that you can take that into account. So I need to display the fuse box, right? So I need to say record dot first story for that specific row and that specific column should be equal to going to be equal to the fuse box. Fuse box. Wait. There's something that we have here. I totally forgot. We have the number of fuses. I don't know if it's the number of fuse boxes or just fuses. It's the number of stairwells and fuses, but I think it's fuses. Yeah, it's fuses. Yeah, there's the fuse. Black box. The black circle. I mean, so yeah, the fuse box is just a star. It's just the box. So it's just one thing. So it's fine. I'll just leave it like that. It's just one thing. Yeah, it's just one thing. We've placed the fuse box. There it is here. So let me just write comment, place the fuse box. And then I'm gonna have place the what? What's next? Yeah. Okay, before I place it, around the thingy, the fuse box, I need to have 5 sides as per image. So I need to have those 5 sides, what is this? 5 sides as per image. So I need to have these 5 sides around it. These ones I need to have them around it. What is it called? Um, darkness, blue, gray, squares. Um, it's really not there. Yeah, it's not there. I didn't put it, you know. So let me see. What can I use to define it? Okay, so I'm gonna use an exclamation mark to define the things around the sides. So I'm gonna edit the enum and add sides. So I'm gonna need sides for the game. And then I'm gonna say comma exclamation mark. So the exclamation mark is going to be surrounding this fuse box. So let's do that. Let's make it surround. How do we surround? Let's try to understand the logic. So notepad, let's see. If we check here, notepad, so we're gonna have a current location, right? The fuse box location, right? We're gonna have that, which is the int. I've called it int row and int column. So we're gonna have those two things. We're gonna use that information to display to display around the thing in the to display around the fuse box. We're gonna use its current location. So if we check here, it starts at this it starts at its current row. This is the current row here, and then it stops at exactly this row plus one. No, row minus one. Yeah, row minus one. Yeah, or you can say it starts at row minus one and then stops at the specific row of which the feature is in. So it's something like this. So if you check this, it's going to be like this, right? So let's do that. Let's try to decipher this formula. So I'm gonna have this and then this. And then I'm gonna have, let's say it's here, right? There's the fuse box. There, it's there. So that means I need to surround these areas around it. So we can just do this, and to kind of see the formula, we're gonna place the specific rows and columns so that we see what changes are made in order to derive that formula. So let's see. You start from 0, this row, and then you start from 0 and then you stop at exactly this row, the row of which the fuse box is in. So basically, what's this row? it's the current row minus 1. So that's my starting point. Starting point is going to be current row, which is int row minus 1. And then stopping point for my rows. This is my rows, right? For now, I'm just talking about rows. Stopping point will be exactly int row. And then I'm going to have, let's look at the columns now. Columns, it's looking at this current location. Columns, it's I start at the previous location, which is this one. So how do I find that? It's current column minus 1. That's how I get 0. So starting, that's where I start. It's current column minus 1. Then stopping point, it's plus 1. As you can see, my current column is 1. So how did it change to 2 to become, in order to become 2? I added 1 to the current column. So I need to do that. Int core plus 1. Then there's our formula. Then we're gonna take it, and then I'm gonna go inside here, and then I'm going to make those changes, right? So let's do this. We have that. I need to know the starting points. So I'm gonna have the for loop for the rows. Int row, you start at what? Int row minus 1. That's where you start. And then you stop at exactly, so less than or equals to equals to int row. That's the stopping point. This one, we have it, that's the stopping point. And then what are we doing? We're incrementing. If you check, if I start here, how do I get to the next value? I increment by 1. So I need to increment. So that's what's going to happen, increase by 1. And then we're gonna go through the columns now. Int C is equals to 0. No, int C starts at what? Int column minus 1. That's where it starts from. And then it stops at what? Column is less than or equals to exactly int core plus 1. And then C plus plus. And then there we go. We have our formulas. We have a formula. So now let me place the sides. So let's place the sides here. So I'm gonna place the sides. I'm gonna say rec world dot first story for that specific row and column is equals to the sides. I don't know why it's not highlighting, or maybe it's new. Okay, I think I hadn't refreshed, I haven't compiled this header file. That's why I didn't know. But here, there we go. We place the size. We know that's covered. Now we move on to the next objective. So let's see, what's the next thing? The torch cabinet appears in a random column of in the last 3 rows. So let's see, in the last 3 rows, the torch cabinet. Where's the torch cabinet? Okay, network. Okay, network is back. Okay, so the torch cabinet that we're trying to place right now, it's within the first story or first game mode. This one, the one on the left hand side. There it is. It's a triangle. So at least we know where it is. So we're still within first story, still placing within first story. So let's place the torch cabinet. It's placed in the last 3 rows of the ground floor. It does not appear in the same column as the fuse box. So you don't place it, okay, in the same column. So you avoid the column of fuse box. this column. It shouldn't be anywhere near the column of fuse box. And we place it the normal way. So let's do that. The normal way, which is just random. I said it's in the last 3 rows, right? What are the last 3 rows? Let's check. Let's try to count. What is the last 3 row? What is this last row? It's the number of rows minus 1, right? So that's my stopping point. And then what's going to be my starting point? This is not the this is not the bed. I needed to count up to 3. So it's going to start somewhere here, right? Which is there. That's the first row, row 2, row 3. So these are the last 3 rows of the game, right? So how is it going to find out? You're going to find out this row. You're going to find out that, remember that this is going to be int rows minus 1. So how do I find this? 2 is just this answer. 2 is just this answer minus 1, which is basically 3 minus 1. So it's going to be this answer minus 1, which is just basically int rows minus 2. That's all there is. And then you do the same thing for this one, and then we're gonna get here int rows minus 3. So in order to get the last 3 rows, so in order to get to generate within the last 3 rows, it needs to be here. It needs to be here. So I need to start at int rows minus 3 and stop at int rows minus 1. Those are the last 3 rows. So let's do that. So for rows, still this row, for rows, I'm starting at int rows minus 3. And then I stop at int rows minus 1. That's how I display in the last 3 rows. And then I generate a column, right? And remember, it's a randomly generated. So random column between int rows. Okay, so let's do something real quick. They said it shouldn't be in the same column as my fuse box. So my fuse box, I've used these 2 values to store it. So this is the location for the fuse box. And they said it shouldn't be in the same column as the column of the fuse box. So I'm gonna need this value here. So I can't update it here. I can't update it there. So what I'm going to do to make things simple, I'm just going to create new variables here and just say row, row and call. Just going to call it row and call, int call, like this, because I'm going to need this value here to compare it with this column, the random column that I've generated. Int calls minus 1. Then I'm going to say while the column that I've generated is equal to the column of my fuse box. While it's equals to that column, copy this and then keep generating the column. Because I said the column shouldn't be the same as the column of your fuse box. And then I shouldn't also place it on top of a fuse box. So we need to take that into account. So I need to have while rec world dot first story for row and column while it is equals to a fuse box. What should happen? Keep generating the rows, the coordinates, the row and the column. And then there we go. Place the fuse box and then what am I placing here again? Okay, where's the sides? Yeah, here I need to say place the 5 sides. That's where we place the 5 sides. So after we've generated this, we've verified. Now we can set it, since now we are sure that it's following the right the right rules. It's following our game rules, and that's where I need to display the torch cabinet, right? So is equals to torch cabinet. There we go. I display the torch cabinet. So here I'm placing the torch cabinet. Place the torch cabinet. So that's what I'm placing there. And then we are done there, done deal. Now we move to the next. The stairwells are randomly placed. Let's see, they are randomly placed in the same position in both the ground and the basement. They may not appear in the same column as the fuse box. The stairwells. What are the stairwells again? It's the crossed circle. And I have specific number of stairwells. And they say they shouldn't be placed in the same location as our fuse box and what else? As the same location as the fuse box. Okay. So by when they say they're placed in both the ground floor and basement, they mean that in both halves. In both halves. So remember the first half is the basement, and then no, the first half is the ground floor, and then the second half is the basement. So that's how they're viewing it. As you can see, this line is written in bold to show you that there's divisions here. But yeah, now we have a perfect understanding of what's going on. You shouldn't place it on same location as the fuse box and a torch cabinet. Okay, they didn't talk about a torch cabinet, but we're gonna assume that it's also important. So I need to generate, and okay, once I'm done, I can reuse those variables now. Int a random location. They said anyway, right? Both ground and top. Yeah, so both ground and top. So that means it's going to be int rows -1, like that, and then int call is equals to random 0 to int calls -1. And then I'm gonna have a while loop, check all different conditions. So if recworld dot my first story array at that specific location that I've generated using the row and the column that I've generated, if it happens to be a torch cabinet, let's say it's a torch cabinet, right? Or it's at least one of them, one of these. And it has to be one of them because if you think about it, you can't have two features in one location. So that's why I'm using the or operator, because you can have one of them. So world dot first story int row, and then this one is going to be int column if it's equals to a fuse box, right? While that's the case. So while that condition keeps being true, it's going to keep regenerating. And if you remember the stairwells, right? We are doing stairwells now. Stairwells have a specific number that we get. They have a specific number that we get from the user, the number of stairwells. So I need to repeat this for the specific number of stairwells. So I need to have a for loop. So for this code here, code that I placed the stairwell, I'm going to cut it. Okay, I think I should zoom out a bit. This should be better so that you can see the whole thing. So you're gonna have this for int s is equals to 0, s less than int num stairwells, and then s plus plus. Then I'm gonna do this, repeat this for the specific number of stairwells. And then now I can, okay, I'm just gonna do it, write the comment here. Place the stairwells. So I'm gonna have that there. Then I'm going to place the stairwell. I'm going to say record the first three int row for the specific int column. Place the stair. What did I call it? Can't I call it stairwell? Stairwells, yeah. It called stairwells. Here we go. We are done placing the stairwells. We've made sure that we don't place it on top of the location. So we have this. The player starts in a random location on the ground floor. So the player starts in a random location in the down floor. The player starts out with neither. Okay, maybe holding a torch. Okay, yeah, we're gonna need to store this information here. So maybe holding a torch. So this information is very important. Any number of fuses. We're already storing the number of fuses. I don't have to worry about how I'm going to keep track about that track of that information. The important thing is maybe holding a torch. So I'm gonna create a Boolean variable inside my game structure. I'm gonna have Boolean is holding torch. So it's gonna be is holding a torch. I'm gonna create it there. Is holding torch, or let's just say as torch. Yeah, just keep it very short, sweet, and simple. It is a torch. The player has a torch. The player starts out in the ground floor. Thing that I want to understand is the ground floor and the basement. Oh, I think I understand now what they were talking about. So one of them is the ground floor. So this could be the ground floor, and then this is the basement. So there's one of them has to be, let's check here. The torch cabinet appears in random location, three rows of ground floor, of the ground floor, of the ground floor, the torch cabinet. So this is going to be the ground floor. This is the ground floor, and then this is going to be the basement. So we figure that out. But for some weird reason here, it says the player starts in random location on the ground floor. And if you check here, the player is here. So does this mean that this is the ground floor? It's a bit weird. There's two worlds and they don't really talk about the basement here. Okay, the fuses are placed randomly in the basement. Okay, now let's start talking about the fuses. Black circle, like you see, now they're really confusing the way they created this thing, because now we see a fuse, right? They said a fuse is a black circle. That's a fuse. Where's the black circle? It's here. So this means this is the ground floor. This is the base. That's the basement, right? This is the basement. Okay, that's fine. Okay, that's fine. And this is the ground floor. So okay, so far we've been doing okay. It's in the ground floor. Ground floor. So we have ground floor and basement. So the one that I've been calling first story, that's the ground floor. So I'm gonna call this ground floor array, and then I'm gonna have this one called basement. And then what I'm going to do is I'm going to rename this, I'm going to refactor, and then there's a setting here. It was, yeah. So whatever changes I type here, they're going to be made throughout. So dot ground floor. There we go. It fixed all occurrences of that variable. And then second story, I'm gonna have select all and then delete second story. This is now the basement. Then done. Let's fixed everything. So we fixed everything. It's placed on the ground floor. Because if I use ground floor and basement, it's gonna make things very easy for me to understand. The player starts in a random location on the ground floor. I don't see the player though here, but okay, that's what they said. They say it starts in the ground floor. So the player starts on the ground floor in a random location on the ground floor. So I need to generate a random location. And if you noticed, we're gonna need something. Remember, we have a variable that stores the player's location. So we're gonna need to use that variable. So what I'm going to do is that record structure. I mean, we have this record structure that stores the player's location, that keeps track of that location. So what I'm going to do is that when I initialize here, when I initialize, what I'm going to do is I am going to, when I call the alloc function, allocate world function, I'm going to pass in that record structure with the player's location so that I can store the player's location too. So it's going to be player location, then rec location, because I also need to store the player's location. Okay, I don't really need to be doing this, but yeah, we'll try to find a clever way to fix this, to store the player's location. A clever way, but this is a very nice way of storing the player's location. So rec location, so I'm gonna need that after I've generated the random row and column. So int row, let's check, let's generate. And they said it can be anywhere in the world, basically, that there's no restrictions. So it's going to be int rows -1. And then I'm gonna have int column, which is equals to random from 0 to int calls -1. And then I'm gonna have a while loop to check if it is the thing, the if I've tried to place into one of the features that I already have, or rec world dot ground floor specific row and column is equals to, what's the other thing? The stairwells. That's the other thing that I've placed there, the number of stairwells. There we go. If it's equals to, then keep generating. Once it is done, then I'm gonna place the player. I'm gonna place the player in the ground floor. So I'm gonna need this line of code. And then I'm gonna say is equals to player. And then I'm gonna store the player's location. So rec world, rec location, and I need to take it by reference. Remember, I'm updating this record structure. I need to take it by reference. So take it by reference. There we go. and scroll down. There we go. Replication that int row is equals to that int row that I've generated. And replication dot int call equals that int column that I've generated. Then there we go. Oh, okay. I think I have a clever way. Yeah, I think I have a clever way. Yeah, I do have a clever way. We'll try it out. I'm not sure, but we'll try it out. The way to store this player's location. So the player may be holding a torch and any trees. So the player starts out with neither. So okay, we also need to store the number of fuses. The number of fuses that I think the number of fuses that the user has collected so far. So I'm gonna have int and then int num fuses collected. Yeah, the number of fuses collected. So they said the player starts out with none. So I need to update my. So yeah, the player starts with no torch. So that means this is going to be false. And then rec world dot int num fuses collected starts with 0 when you begin. So that's what it means. The player starts with neither. He has no torch, he has no number of fuses. And then I'm gonna have the number of fuses placed in the fuses will be placed in the basement. So this fuse is the black circles, these ones, and they're placed in the basement. But where's this thing? The stairwells, what did it say about the stairwells? I randomly placed in the same positions, or in both the ground floor and basement. I missed that. So it's in both the ground floor and basement. I missed this, the stairwells part. So I need to place it in both the ground floor world dot basement, right? And then for that row and that specific column, stairwells like this. So they need to be placed in bold. And then what I'm going to do, right? Mm, after it is placed, yeah, there's something very important here to validate, but we'll validate that late. So let me do this. The basement is different from the ground floor. So I'll just have the ground floor's code separate, the basement's code separately, I mean. So this is going to become basement. And then now, the only thing that I'm going to check here is I'm going to check if I'm not trying to place into a location that's already occupied with the stairwell. So stairwells, if it's already occupied, then regenerate. And then it's gonna give you this output. So that's what I was trying to fix here. Because you might generate a location that's with a random location that's already occupied with a stairwell. And if you check this while loop, it doesn't take that into account. So I need to take that into account. I'm going to say, oh, rec world dot ground floors uh, features for the specific row and column if it happens to be a stairwell. If it happens to be a stairwell, regenerate. because you're gonna place on top of that feature again. That's what you're trying to avoid. The other parts, you don't have to worry about that because let's see. Uh, Darkness. Okay, yeah. So with the fuse box, you only place it once. You don't have to worry about all the other things. And then you just add some sides. Yeah. And we also have sides. I totally forgot about the sides. So when you place the torch cabinet, they said you must make sure that it's not what? It's not the same column as the fuse box. And while I'm placing this, I need to make sure that it's not on one of the sides. Yeah, we need to also take that into account because that's why sometimes your code may not run. So let's do that. So while this, and then for the specific row and column, if it's equals to sides, then what should happen? Oh, okay, we already have that code. So what I'm going to do, right? I'm gonna combine these two. I already have a while loop. So if it's equals to this, if I happen to be in a fuse box's location or a sides location, because we also have sides. We place them manually, but they're also there in the game. We don't want them to be overridden with new characters. We don't want that. After I'm done, I can place the torch cabinet after validating. And then you place the stairwells, right? Every time you place something, you need to make sure it's not equal to the sides. As long as I'm placing it on the ground floor, it's not equal to one of the sides. We have that. Ground floor. Wait, what am I missing? I think I didn't fix something. Okay, stairwells. Oh, I didn't change this. It's a basement. I didn't change this to basement. Okay, so the basement has no stuff, there's no sides. So I don't have to validate for the basement. But then here, when I place the player, I might try to place the player in a location that already has one of the sides. I don't want that to happen, so I'm gonna put that there. Then once I'm done, I'm gonna place everything there. And then let's see. If fuses are placed randomly in the basement, so now I need to place the fuses in the basement. So I need to have placed the fuses in the basement. So I'm gonna have a for loop int f is equals to 0. Then f is going to be int num fuses. Then f plus plus. There we go. And then I'm gonna start placing, right? So I'm roughly gonna do something like this. I need a random row and a random column. So roughly gonna do this. And it's anyway. Okay, it's in my basement. So I'm gonna need the code for the basement. Then I just give it more functionality. There we go. And then I'm gonna say if it's equals to stairwells, or what else could it be equal to? What do I currently have in my basement? I have the stairwells, and that's it. It's just the stairwells. Yeah, just the stairwells. And then here I'm gonna have fuse to place the fuse. And then that's pretty much that's the gist of it. It's everything. So let's try to print now. Let's print our game world. I'm gonna have for int, I'm gonna go through each row and column. It's equals to R and then less than rec world dot int rows R plus plus. Then for int c is equals to 0, c is less than rec world dot int calls c plus plus. And then I'm gonna say c out my features, and then I'm gonna index using my array, which is the rec world dot. Okay, I need to know the options, but we'll do that later in the next session. I need to know whether this is a basement or the players move to the ground floor of the basement. Then they're gonna see the different world based on where they are located. And then I'm gonna separate everything with the space in between. And then after each column, basically it's gonna have this. So far it has this. This one line. So after the last column, which is going to be this, start on a new line so that outputs it like this. Start on a new line, start on a new line. Every time after the last column, that's what I'm trying to do, right? So I'm going to have C out here and line. There we go. It's done. And then, okay, I'm just gonna pass in values. I won't read. Okay, rec world. I will not put in the command line arguments because that's gonna take time. So I'm gonna have just the columns, just gonna put the columns here. So let's say 15 by 20, the number of stairwells, 3, 4. And then, yeah, I also need the record structure for the player's location. So player, location. I don't know why it's not highlighting. So rec, location. Yeah, and then I just pass it. Remember, I'm gonna pass it by address, so it's gonna update whatever's there, even though there's nothing there yet, but it's gonna update it. So once I'm done, I'm gonna call my print world. It is print world, right? Print world, which takes in a record structure, then end. So far we haven't done the deallocation and stuff, so we won't get into those details. So there's our game world. As you can see, there's the, oh, okay, I see now. It's displaying, wait, it is the right game, right? Okay, let me just make it 10 by 10. I'm not sure if it's displaying two worlds at the same time or it's just the size that I chose. Yeah, there we go. That's a bit better. So now the thing that I need to fix is here. Yeah, I need to make sure I don't replace the fuse itself, the fuse box itself when I'm placing that feature. So let me see, fuse box. When I place the fuse boxes, it is, yeah, that's not it. Yeah, there it is here. So when before I place the sides, I'm gonna check that location. I'm gonna check if rec world, I'm gonna make sure it's not equals to my fuse box. So if it has to be, must be not equals to fuse box. And then I'm gonna place it. shouldn't be equals to fuse box. Or you can say continue. There's different ways to approach it. Yeah, but it's not displaying though. Something is not right there. What am I missing? We did do everything, but okay, that should be fine for now. We're gonna continue where we left off.